Whenever we see evaluate, what that means is we're going to crunch the numbers. That's what evaluate means. And so in this case, all we have is numbers. There's no variables. So we're going to evaluate and simplify the expression. We should end up with just a single number. So following order of operations, you could try to type this all in your calculator. And I don't trust calculators all the time. If you've got a calculator you trust, then you could go ahead and type this whole thing in. However, what I would probably do here is I'd probably split and do the two parts separately. In other words, the 2 to the 4th power and the 4 to the 2nd power. And if I do both of those separately, well, they actually both end up being 16. So 16 plus 16, then I can do that math pretty quickly, 32. Okay, so evaluate just means we're going to crunch the numbers, but be careful we don't just trust whatever our calculator spits out. Evaluating this expression, we have something kind of scary. We have a fraction. And to make it a little bit scarier, we have a fraction as an exponent. Now, if you don't have a calculator that can do this, then you need to quit and pick a different calculator, okay? You want to have a calculator that can allow you to type whatever exponent you want. And so this one, you can type it as 1/2 or just 0.5 as a decimal. That's really the same thing as a square root. So when we say 1/2 power, that's like saying the square root. So this is actually the square root of 64, or just 8. Compute the total cost per year of the following expenses. Now, one thing that's very important is to be able to put your expenses on a common time frame. So for example, in this example, we're spending $22 every week on coffee and $136 per month on food. Well, those are different time frames. So even though it sounds like we spend a lot more money on food than we do on coffee, one's in as a week, one's per month. So what we're going to do is we want to scale those to the same time scale. The question says over the course of a year, so we're going to go ahead and scale both of them. We're going to take into account that there are 52 weeks per year and 12 months per year. And we're going to use those facts to scale those up. So $22 every week means 22 times 52 would tell me how much per year, and 136 per month means I'm going to do 136 times 12. When I multiply those out, now I'm comparing the same time scales. They're both per year. So now when I compare it, I can go actually subtract and find out how much more am I spending on food than coffee. And so in this case, I'm spending $488 more on food than coffee per year. Now that we have it in the same time scale, it makes it a lot easier to compare. When you're deciding your cash flow and taking into account your monthly expenses, you need to remember that you don't pay all your bills every month. What I mean by that is some things you only pay every 6 months or every other month. So in this example, we have land paying a semi-annual premium. That means that land is paying their semi-annual premium every 6 months, twice a year. Also have a monthly premium for health insurance and an annual premium for life insurance. So those are all on 3 different time scales. So if we're going to calculate our monthly expenses, we're going to want to scale each of those to find the average cost per month. First, we have the $700 big automobile insurance, but that's every 6 months. We have the monthly premium that we do pay every month, and then the annual premium that we pay every 12 months. We're going to scale it down and divide each of them by the number of months so that we then match our terms. And so when we go ahead and divide each one by the number of months, it gives us an average for each month for each expense, giving us a total of $324.17. Now, when you're making a budget, whether it be personally or for a business, we might call that a cash flow. We want to figure out how much money is coming in each month, income, and how much money we're spending each month in expenses. And so for this example, we notice that we have a couple sources of income and we have a bunch of expenses we have to figure out. And the key to doing a monthly cash flow is to include things that don't necessarily have, for example, one cost per month. Like groceries, you might buy groceries every week, so you need to account for that multiple times. Some things you won't pay every month, like car insurance, you might only pay twice a year, so you need to scale that down to fit the appropriate time frame. For this one, we're going to assume that 1 month is 4 weeks, just to simplify our math a little bit. We have our income as a salary, plus we have some extra sales that we sell for pottery. And so we're going to find that net monthly cash flow by first finding the average monthly income from each of those sources. So the monthly income being, well, we're going to take that yearly salary and divide it by 12. And then the pottery sales is already in a month, so we're just going to say plus 196. Our monthly expenses we have to pay close attention to, because for each line we need to pay attention to whether we pay it once a month, whether we need to count for it 4 times because it's weekly, or whether we're going to count for it multiple months and we have to scale it down. For example, donation says $660 a year, so we need to divide that by 12 to make that work. If we do run all the numbers, we end up with $2,418.33, which means we actually spend less than we make. That's great news. It means we're going to have a positive cash flow. Actually, we have extra $719.34 in that cash flow that we get to figure out where we're going to spend that. Now, when we're talking about interest, we can have good interest in savings accounts, but we can also have bad interest. In other words, the interest on purchases, for example, in a credit card, or if we finance a purchase and we buy something on credit. For example, if Vic bought a new plasma TV for $2,300, he got a nice TV, and then he went to the cash register and they said, would you like to actually only pay $100 today and then finance the rest at 0% financing? You just got to pay every month and pay it down, and there's no interest or anything. You just get free delay in paying it back. Now, if Vic takes this deal, which he did, and then makes the mistake of forgetting a payment. In this case, Vic forgot about this monthly payment and did not pay his first payment. And a lot of times when you make these financing agreements, even on a credit card, if you miss a payment, they actually will raise the interest rate. So Vic ends up having to pay a 5% interest per month on the balance every month so that he can pay back that privilege of not paying it all up front. So his upfront cost was $2,300. How much is he paying every month in interest? Well, we need to first account for the fact that he did pay $100 off, so he only financed $2,200. And 5% of that $2,200 is going to be his monthly interest, his finance charge. So he's paying $110 a month just in interest. So even if he pays $110 every month, after a year, he'll have paid quite a bit of money, but he'll still owe $2,200 because that's just the interest. Calculate the amount of money you'll have at the end of an indicated time period, but here's the catch. In this problem, we're going to use simple interest. So if we invest $2,000 in an account and it only pays simple interest, that means every year we're going to get 2% of what we started with. Simple interest, you get interest only on what you started with. And so what we started with was $2,000. So to figure out our simple interest, we just multiply what we started with times our rate times our time. And so we'd say we made $800 in interest. However, that $800 ends up being just the profit. The question says, how much money will we have at the end? We're going to have $2,800 because we have to add the $2,000 we started with. Use the compound. Now, if we were to do investments in compounding interest, I'm going to be honest, I usually default to not doing that stuff by hand because I want to use a calculator that's going to take into all the stuff really easily. And for that, I use Microsoft Excel. You can use Google Sheets if you don't have Microsoft Excel. It's going to be the same formulas. Now, there's 3 big ones we use in this scenario. One is the PV function. That's for the present value, or how much do I need to save now? How much do I put now? The FV function is how much will I have in the future? And then the PMT function is how much do I need to pay monthly or save monthly? Do I need to add a monthly amount to my account? So in this case, it says use the compound interest formula, and these all do compound interest formulas all automatically. These aren't simple interest. Determine the accumulated balance after the stated period. So my stated period is 5 years, and I need to know my future amount. So that's going to be my FV. And when you use Excel, lays it out for you and it gives you hints as you're typing it in. So I'd start by typing the equals FV and then the parentheses, and then it'll walk me through the rest. You can see I have to put my rate and then my number of periods, which is just, in this case, 5 years. I'm not making monthly payments in this case, so I'm going to put 0 for PMT. And then lastly, I'm going to put my PV, my present value, my lump sum that I have in the present, which is $8,000. When I put all that in, I can press enter, and it gives me my answer as $11,754.62. So if I put $8,000 invested at 8% for 5 years, compounded annually, it'll give me that result. So if you want to find your savings plan balance in the future, we could use Excel to do this kind of math. And there's 3 main functions I use in Excel using compound interest. And so this one is obviously going to be the future balance. So I'm going to use FV for my future value. When I start typing in equals FV with the parentheses, then I can walk through each of the things that it needs, which first, it needs the rate. I'm going to type that in as 0.07, but you could actually type that in as 7% and use the percent symbol. But this says monthly payments. So we're making monthly payments. So I need to switch my annual rate to a monthly rate. And so rather than just write 0.07, I need to divide it by 12. And so I get 0.07 divided by 12. And then I have 3 times 12 for my number of periods, because again, we're scaling it down to monthly. So I'm not just making 3 payments. If I'm making monthly payments for 3 years, I'm making 36 payments. And you could type in 36 there. I'd like to put 3 times 12 so I can keep track of where the numbers came from. Then when it says PMT, PMT is the payment made each period. And so in this case, it says I'm making monthly payments. I'm adding to my savings account $100 each month. And then I could keep going and I could say how much am I starting with is my next thing. But I am starting with nothing. So I'm going to leave it as just right here, and I'm going to close it off. I'm not going to put anything for PV. If you want, you could put a 0 in there. And it calculates for me. It says that $100 a month after 3 years at 7% will add up to $3,993.01 in my bank account. All right, this is a common scenario. People want to know how much they need to put away now and let it grow so they have money in the future for a big purchase. In this case, in 6 years, this person would like $55,000 for a down payment on a house. And so, assuming they're not going to put any additional money aside, they just want to put aside enough money, let it grow to 55 over the next 6 years. How much money do they need to put down? Now, an important caveat here, important feature is that they only have a 4% interest rate. So they're going to get compounding, and it says annual compounding. So let's go ahead and use Microsoft Excel to do this problem. Now, which one do we want? Do we want to know how much they'll have in the future? No, we know they want 55. We don't want to know how much they're going to save monthly because they don't want to put aside any monthly. What we want is how much should they save now. So we're going to use the PV function. So we're going to type equals PV and then open parentheses, and then we're going to work our way through each one. We can put the interest rate as 4% or 0.04 as a decimal. Now, normally we have to divide that interest rate by however many times we compound per year. Like if it's monthly, divide by 12. In this case, it says annual compounding. So we're just going to divide by 1. And then the same thing for the number of years. We have 6 years, and they're only compounded annually, so we don't need to multiply it by anything, but we're going to multiply by 1 just because we compound once per year. It says 0 monthly payments. They're not making any additional deposits. And they want that $55,000 as their future value. And then when we enter that, it says if they set aside $43,467 now and 30 cents, it'll grow to $55,000 in 6 years. We're going to use the compound interest formulas. We're actually going to use Microsoft Excel. And we're going to look at this semi-annual compounding to determine the accumulated balance in stated period. Accumulated balance, in other words, in a few years, how much money will they have? And it says we are going to deposit $12,000 at 4% with semi-annual compounding for 5 years. So we want to know the future value. And so we can use that Excel formula for future value by typing in equals FV and then parentheses. And then we're going to put semi-annual compounding. What does that mean? That means twice per year. So we have to divide our interest rate by 2 because it's twice per year. So we're going to put 0.04 divided by 2. And in the same way, we have to multiply our years by 2 because there's 2 compounding periods per year. They are not going to make any monthly payments, so we're going to put 0 there. And then we need to put their present value, that 12,000 we started with, right there at the beginning. So we're going to put that right there, and we're going to close our parentheses. And Excel gives us that 12,000 in just 5 years at pretty low interest rate is going to give us $14,627.93. 17 years after purchasing shares in a mutual fund for $5,900, the shares are sold for $11,100. So that's a profit. But we don't want to just say we made money. We want to say, was it a good investment? What was our return rate in both our total return and our annual return? So let's start with the total return. Total return is kind of like percent change. We just take the amount we sold it for minus the amount we started with, and we divide it by the original amount, and then we multiply by 100 to turn it into a percent. That gives us the 88.1%. So that's a good return. That means we made 88.1% of our money on top of the money we started with. So we almost doubled our money. That's a good return. However, it's worth noticing that this did take 17 years. And so for 17 years, you had to wait for that to get to 88% profit. So another thing we got to look at is the annual return. The annual return means we're going to take how much we ended with, the amount we ended with, divided by the amount we started with, and then we're going to raise it to the 1 over y. And so in this case, 1 over 17 power, because we need to account for the number of years. And then we're going to subtract 1. And what happens when we do that is we get 0.038. Now, we do also want to multiply by 100, so we have it as a percent. So that means at an annual basis, since it took us 17 years, we actually only made 3.8% per year when we talk about the annual return. So it's important to look at both our total return and how much money we made, but also our annual return. And that really reveals whether the time it took for it to grow was worth it. One way you can evaluate stocks is with something called a PE ratio. So we have a PE ratio of 10.91, and this particular stock also had a price per share of $99.86. And so a PE ratio, the first thing we're going to do is, all right, we know the price. The PE ratio is actually the price divided by the earnings. And so we know price divided by earnings is 10.91. So we can actually figure out how many earnings there were per share by just plugging in our price that we have and then solving that for E by multiplying by E on both sides and dividing by that 10.91. We do that, we end up finding the earnings about $9.15 per share. And so that company is making a profit. And this isn't a terrible earnings amount, but it's in the context of what the price of that stock was. So since that stock was priced at $99.86, that's a pretty low earnings for that price. In other words, when we look at the PE ratio, it takes into account the earnings and how high the stock is trading at. In this case, it's trading at 10.91 as a PE ratio. And so when we see that, we have to say, where's that normal? And so historically, this stock has a PE ratio between 12 and 14. So a PE ratio of 10.91 is actually low. It's actually an underpriced stock. And so that means it might be a good buy because the price is low considering the earnings based on the historical data. How long will it take your money to double or triple is an often common question, but we need to take a look at this question. First off, I need to mention triple. If your money was to triple, does that mean you make 300% returns? No, that means you make the principal plus a 200% increase. So that's a total return of 200%. And that's how you triple your money. So, with that being the case, I want to teach you a formula. And that's the log of 1 plus the total return over the log of 1 plus the annual return. And if we do that, it'll actually give us the number of years it'll take. And so I'm going to go ahead and take this into consideration for this problem. The total return being 200%, so we have log of 1 plus 200%, and the annual return, the APR, being 8.5%. We're We're going to convert both of those to decimals. Well, 200% ends up being 2.0, so if we do 1 plus 2, we get 3, and the 0.085 ends up giving us a 1.0885. Now, if we do the log of 3 divided by the log of 1.085, which is just a button I have on my calculator, if you have a scientific or a graphing calculator, you'll have a log button. You might have LN, but you'll have a log button, and you can go ahead and use that here. And so I'm going to say it's going to take us about 14 years. I'm going to round up to the nearest year, 14 years for us to triple our money if we have 8.5% interest rate. If we have $1,000 deposit in an account that pays an APR of 6.5% annually, how long will it take us to reach our goal? Now, this is assuming we're not putting more money in. And you might say, oh, can we use Excel for this? Well, Excel has a function for figuring out how long something will take, but it's kind of weird. It's kind of difficult to use. So we're going to not use it because it doesn't work maybe like you'd expect. So we have our formula that we've used before, which is using log of the total return over the annual return, and that should give us our years. So we're going to go ahead and first calculate our total return. We know our annual return is 6.5%. That's given to us, but our total return, we need to find how big of a percent increase is it to go from $1,000 to $160,000. So we're going to type that in and calculate, and we get that's 159% return. That's a good. You took 1,000 and went to 160. That's a big total return. It's going to take some time. So when we consider our annual return, we're going to go ahead and put these in decimals. So that 100% is just 159. The 6.5% is going to be 0.065. And we're going to do 1 plus each of these, and we're going to take the log of each of them. When we do that, we get 80.59, which means it's going to take us 81 years. And we're going to round up to 81. We're going to say at the end of 81 years, we're going to have reached $160,000 without having to make any more deposits. If you have any questions, put them in the comments. Let me know.